Welcome back. Today, the topic is calibrating or recalibrating a scanning laser Doppler vibrometer. I have one of our senior service engineers, Andrew Goldberg, to walk us through the steps. So here we go. All right, Mr. Senior Service Engineer, Andrew Goldberg. We did a video about single point vibrometer calibration a few days ago, and now we want to do with, it's a similar one with the scanning LDV. So imagine I have a nice PSV 500, 400 Q-Tech, and I'm sending it your way. Can you take us through the steps before it ships back to me?
Yeah, sure. It's very similar to what we do on the single point systems. We'll usually start with an optical alignment and optics and laser health check, make sure nothing's broken. The laser has good output through the system, depending on which version it is, be it the HENIs or the IR systems. They have different requirements. We make sure that everything matches our requirements in the specs. Then we'll go through an electrical test. Again, just like the single points, we do a synthetic Doppler signal, send it through the system, take a measurement at 70% of full scale. Once we know that all of that testing passes what we expect, we'll do a final test with a calibrated shaker that's NIST traceable, make sure that everything lines up there as well. What does come out different, though, for the scanning system is we also have to do a reference channel check and a generator check. So depending on which system you have different numbers of reference channels, anywhere from 1 to 8 on the reference side and 1 to 4 on the generator side. And we'll use the same function generator to create a synthetic sine wave at 1 kilohertz into the reference channels. And we'll make sure those are all operating correctly. And then we'll also use the generator and just output directly to a multimeter, usually at 1 kilohertz with a 3-volt amplitude. And they have their own tolerances to make sure that everything passes that testing. So it sounds straightforward, but it isn't.
Yeah, you make it sound easy.
Simple.
I like it.
When you've been doing it for 10 years, it does come across as easy.
So let me summarize. So it was basically as opposed to 3 steps, when it comes to scanning LDV, we are talking 4 steps, starting
Correct.
with optical alignment and the laser check. Step 2 is the electrical calibration. Step 3 is the mechanical end test. And step 4, which is the new one, is the data acquisition check, where we do check the ref and the generation channels.
Correct.
And once done, the calibration is good for?
Depends on what the customer requests. Most of our customers stick to Germany's recommended 2 years. We're working towards becoming ISO certified, so we can't recommend an actual calibration cycle, but most of our customers tend to stick to that 2 years. We've had a couple that have dropped it down to 1, and just yesterday I had a customer ask if they could extend it to 3. So kind of depends on what the customer is looking for.
Whatever the customer wants.
Yep.
Love it. You're the man. I think that's it. You answered all the questions. 4-step process. Sweet, straightforward. That's what happens with 10+ years of experience, I guess.
Yeah.
Thank you very much, Andrew. This was awesome.
You're welcome.
All right. Now that we know what the steps are, here's a 1-slide summary of what Andrew just explained. 4 steps. The first 3 are similar or same to single point vibrometer calibration with some differences. The optical, electrical, mechanical, and these are the first 3 steps with the optical alignment, laser power output check. Then we do the synthetic signal insertion and do the electrical calibration. And then we top it off with a mechanical end test. What's different is the step number 4, the data acquisition calibration, which is an integral part of the scanning LDV. So that is also done and is an additional step when it comes to scanning vibrometer calibrations. So there you have it. Thank you very much. Hope this was helpful. Reach out to us if you have any questions. There's our email or phone number. and we'll be happy to walk you through more details. Thank you.